So as you see the diagram here, I have implemented area 0, backbone area. I have implemented area 2 here, non-backbone, and I have implemented area 1. They are all configured. Now just I need to configure this NXOS. Rest all devices are configured. And the point is to reach this network. This network, just to understand the concept we are doing this scenario, this network is reachable by these two devices. R3 has access to this network, R6 will have an access to this network, and this network is going to be external. So what is the plan? We are going to redistribute the connected network. So we are redistributing connected on R6, redistributing connected on R3. So it would be reaching as an external route to everybody, and the cost everywhere will be 1. Cost is 1, cost is 1, and here the cost is 1. Sorry, here the only thing we have changed is cost is 50, and cost is 1 here, cost is 1 here. And when they redistribute, they are redistributing with OE1 cost of 20. The start point is 20. Similarly, here I am redistributing with the cost of 20. Now, in this, if I come to NXOS and if I try to find 192.168.1.0 is reachable via which path? Will it be reachable via R4 or will it be reachable via R2? Towards this area like this or towards this one? Which one? That's the question. That's what we have to study here, understand here. Now you take a call, you tell me what will happen. What do you think will be seen on Nexus, which is the best? You have all the informations. You can decide, you can calculate, you can decide. I'm just giving a clue.
R2, right, John, because of the cost.
R2 because of the cost. Everybody agrees? Okay, this is up. I'm going to make some changes. Just give me a minute. Let me set this up. All right. So we have interface E1/1.
I think, John, it would be R4 via R4.
Reason?
The reason is like the R6 is redistributing that route, okay, and R6 is owning that route, right? And NXOS having that router discovery via the router LSA1, because like R6 it can be seen on the NXOS, R6 can be seen as a router 1, so it's interval, right? Internal, right? So it's most trustworthy, I would say, in that case.
Okay. So one answer is R4. Okay. So in that case, how about R4? So in this case, the R4 would also be choosing 192.168.1.0 via, in this case,
R5.
should be R5, right?
Yes. Yeah.
So it should be this way because you are saying this ASPR that we are seeing as per the Sandeep's logic, he's saying ASPR in this case is an intra. It is part of our area. But whereas this ASPR, what you are seeing is basically for us, it is inter. It's not part of our local area. It is part of a different area. So that logic Sandeep is applying and he says it is router 4. But what Raj said was based on the cost calculation. He said, as we are looking at the cost value, R2 seems to be the shortest path. Okay, all right. I'm not giving any conclusions here. I'm just trying to explain whatever the answers came in. We will look into it. Just give me a minute. Let me set up this IP rest, all routers are configured. I don't have to configure them. 10.1.1.2 it is. So it will be 10.1.1.1. All right. So back to NXOS. IP 10.1.1.1. Now shut. I would like to set the cost as 1 here. By default, it is taking as 40. So I would like to, I think feature has to come. Okay, let's bring in the feature, OSPF. Just confirming if I have manipulated any network type, just to confirm. 0/0 is pointing it as point to point. Point to point. All right. So in this case, then E1/1 has to become medium, point to point. 1/2 also medium, point to point. I could have also set the cost, IP OSPF cost. I wish it is 1. Cost is 1. Router OSPF. Let's just go with 1 here right now. The router ID, let's fix it as 001. And then 1/1 IP router OSPF. 1 area is going to be 0 this side. On 1/2, it's going to be area to the other side. All right. Hope it is fine. So let's see now. The necessary configurations are done on all other routers. Let us check show IP OSPF neighbor. What I see, okay, the neighborship is coming. Show IP route. You can see the route. We have 192.168.1.0. It is pointing towards R4. Look at that. It is pointing towards R4. So what Sandeep said is right. They are looking at their ASPR, which is internal rather than the cost. Look at the cost. Cost is 72. Let me prove few things for you. Show IP OSPF database here. When I see the database, I can see the external here. Okay. Show IP OSPF database. I'm getting 1.0 from router 3. I'm getting 1.0 from router 6 as well. From both the routers, I'm getting it. Okay, how about looking at the cost? Detail. The cost that I'm seeing is 20. The cost that I'm seeing is 20. Both are giving me 20. Okay. When I look at show IP OSPF border router, I can see the border router I have here. Is it showing only one? Just give me a minute. Let me quickly get into R3. I'm seeing certain missing things here. All right, we will look into that part. So right, this is going well. Let me see on R4.
But when there is two routes, it should be ECMP, right, John? They should
But
be
cost is
seeing.
varying. Huh? There
Okay.
are certain conditions now. So
Okay.
based on the condition only, things are now fluctuating here. Show IP route, what do I see here? Why this is not coming up? Okay, I need to probably do some troubleshooting on this.
Then we can check on the R1 or R2, right? What are the border routers what they are saying?
There is something happening here. Duplicate detected router with a duplicate router ID 001. Okay, R1, I think I had configured the router ID as 001. And I
And the
think this
NSO,
guy is
yeah,
having this
NSXO is also the same.
router OSPF 1 router ID. Hope that should solve the problem.
But it won't change, no,
Yeah,
John.
I'm clear. Okay, now it has come back with 10. So one should, yeah, one is this guy. All right, now I think it should be fine. It was a duplicate router ID causing the issue. Now, if I go to NXOS, check out show IP OSPF border router, so we can look into it. Now it says we have ASPR here, we have an ASPR here. One ASPR is the router 3, which is having a cost of 3 here, cost of 3. Another ASPR is 006, which is having cost of 52. That is R6, 52. Cost is more. Show IP route, when I look into my routing table, 192.168, it is picking up the higher cost. Hope you can understand now what is happening here. So we are having 20 and the cost this side is actually lesser, 20 plus whatever we are seeing, it is very less. But it is still preferring the other side. The reason being here is what we discussed, the intra is preferred. It is preferring the intra. It says this ASPR is internal to my area, I would prefer that one. Whatever is the cost, I'm not bothered. All right. Let's go to router 4 for an example. Router 4. In router 4, show IP OSPF border routers. I can even see the same two border routers. I see R3, which is here. I can see R6, which is here. I can see the cost of that. I can see show IP route. Now the IP route here, 192. 192.168 I have. What is the next hop IP? Look at this. This is where the problem is. So Sandeep is right partially. Even Raj is right. Whatever Raj said is also right. But two different devices they are. Hope you guys are watching it, seeing it and understanding. So whatever Raj said, R4 is doing that. Whatever Sandeep said is happening on the NXOS. Look at the difference. What is the iOS behavior? What is the NXOS behavior? This is the difference in the behavior. iOS is purely depending on cost factor. Our NXOS is depending on the factor of intra and inter. It says intra is better than inter, simple. Now what is happening in your network? A loop is going to happen. A loop is going to happen right now here. If R4 wants to reach the network, say imagine I go to R4 and I try to do a trace route. I would like to reach 192.168.1.1 for an example. So if you see this one, it would start creating a loop.
John, but I could see like in the output of the R4, I could see the area border out with small I and a big I. It's not meant for him in that case.
Yes, that's what I'm saying. That's what I tried to explain. iOS is working on cost, not on the logic what you said. NXOS is working on your logic. Got it?
Mm-hmm.
So you can see here what is happening. It is going to 2.1 and from 2.1 it is coming back to 2.4.
Mm-hmm.
So there is a loop happening here. That's an interesting concept that we should be knowing. When a Nexus is mixing up with an iOS, you can observe what is happening. A loop is getting created here. A loop is getting created. Hope everybody is clear with this. Any questions?
Mm-hmm.
So whenever you mix up and
yeah, please carry on, please, Joe.
So whenever you mix up with this Nexus OS with an iOS, be very careful with this kind of scenarios when you get an ASPR, this logic. The reason is OSPF comes up with lot of RFCs. OSPF has been developed. The RFCs has been changing and it is left to the vendor what they are preferring. And this behavior, whatever you are seeing iOS, is because of an RFC that they are following 1583. This is an OSPF RFC which is working on cost factor. There's a cost. Based on the cost we decide. Later, they changed the RFC to OSPF. They came up with an RFC called 2328. And in this, they came up with a logic saying we will use intra versus inter. Not the cost. We are not bothered about the cost. So there's a lot of confusions. You should remember this. It's all based on the RFCs. OSPF has a lot of RFCs. You should be observing them and you should be working on the device. If you look at Juniper, they are a little different there. You should observe what RFC they are implementing. Based on that, best path selections are different. So iOS, Cisco is using 1583. Nexus OS, they adapted the new one. In iOS, they did not adapt it. When NXOS came, they adapted this one. So Cisco themselves give a warning. This concept is there in Cisco website. They themselves give a warning that if you are using NXOS, remember we are using this RFC. So as per this RFC, we are following this method. iOS is following a different method. You will end up in this problem. So what should I do? You should change your NXOS to use the older RFC then. In this scenario, you can't make your iOS to change to the new because they are not supported. This feature is not there in the iOS. So what can I do? I can change my NXOS backward so that we can adapt to this flow, which I'm going to do now and show you, but hope everybody got the logic what is happening here right now.
But John, going towards it, but I doubt. But the things which we are learning internally, right? We should be accepted. I mean, the old iOS, the RFC, the new RFC should be also be supported. But it's not programmed like that, right?
Yeah, they are not. It's all left to Cisco. If they want to adapt a new iOS when they come up, they can adapt it. But as of now, they have not adapted. So it depends. So it's all vendor decision what they do. So we need to be very watchful. So when things go wrong, we have to look into these things because as per the theory, we think, okay, this is how it should work. But when there's a mix of devices, then the problems can come. Okay. So let's go to this NXOS. And in NXOS, we do have this option, router OSPF1. Under this router OSPF1, there is RFC 1583 compatibility. There is a command available. Just use this command. And now the behavior changes. Now, if I check show IP route, you can see 192.168.1.0 is pointing towards R2. And we are now depending on the cost factor. Okay, we are working on the cost, so R4 is happy now. R4 comes to NXOS, NXOS goes to R2, and they reach the destination. So that's one topology I could design.